everyone. I'm doing more videos, so I'm just going to be going over what we've been doing in class, obviously. And I'm just going to start with balancing basic equations. So, as I think we all know by now, a chemical reaction is when one or more substances are changed into one or more different substances, and that's evident in a lot of different ways: energy change, color change, formation of gas, formation of precipitate. And that a chemical equation is just a shorthand method of showing a chemical reaction. It indicates the substances in that reaction and the relative amounts. So in vocab, we do need to know is reactants, which lead to products, and that's just basically saying what you start with and what you end with. So, that's kind of the main thing, and then we also need to indicate the state of matter. So I think we've all seen this. The little S is solid, the little L is liquid, and it's just easier to make it a cursive L, so that way you don't think it's a 1. Little G is gas. Whoops, my pen. And then the little AQ, if I write it in the right order, is aqueous. And so aqueous basically means solution that's been dissolved in water. So it's a solution of a solid dissolved in water. And that just really happens to make it easier for equations to occur, because you put two solids together, that's probably going to take a long time. And so with the water, it helps speed up that reaction. And as we've seen by now, the aqueous and the solid are going to come into play with with the solubility rules. So next thing that's a bit important is why we have to balance these chemical equations is the law of conservation of mass. And basically what this law states is that matter may change forms, but matter is not created or destroyed, except for nuclear equations. And so that means you have the same number of atoms of each element on both sides of your equations, on your reactant side and your product side, except if it's a nuclear, which we saw last unit. So that's just important. That kind of explains why we have to balance these equations out, because mass can't be created or destroyed. So the steps to kind of writing these, one is to determine the reactants and products. And so basically, you probably will be given the reactants, but in word form, so you need to write that into a chemical equation. And then either you'll be told the products, so you'll have to a lot of times come up with the products. So then the second one is to count the atoms of each element on both sides, or determine number of each element on both sides. So you just need to look and see how much you got. And then a note with that, the number equals on both sides, which means it's balanced. So that doesn't mean you're going to have the same exact, it's not going to be written the same way, but you're going to have the same amount of elements. And then to do that, we use coefficients. We don't use subscripts. Subscripts kind of say how many like atom particles are in there, while coefficients tell you how many of that element you have total. So like if I had O2, that means I have 2 oxygen molecules together, but if I had 2 O2, that means I have 2 sets of 2 oxygen molecules together. So like this would be like this, while this would be this, if that makes sense. Yeah, so don't change the subscripts. Those are going to stay, but you can change these coefficients in front. So let's just start with, this is a synthesis equation. So say you had like hydrogen gas plus oxygen gas produces liquid water. So this is a good time to bring up the diatomic elements. So these are nonmetals that go in pairs. You won't write them, if they're written by themselves, you won't write them without a subscript of 2. So that's going to be hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. There's a little acronym, Brinkelhoff, if you like acronyms. That's how you can remember. And these all come in 2s. So like for our example up here, we would have H2, and that G for gas, O2, and then H2O, because we all know that's water. And so to balance this, I think we can all see that, we have 2 hydrogens on this side, we have 2 hydrogens on this side, but we only have 1 oxygen and we have 2 here. So we need to get this one to 2. So if we put a 2 in front of here, well, now we have 4 hydrogen. You multiply these together. So we need 4 over here now. And now you're balanced. So we have 4 hydrogen, 2 oxygen, 4 hydrogen, 2 oxygen. And that is basically how you balance these. I know you've done a lot of practice in class and through the OWLs, so I think everyone's probably good on this. If you have questions, you can always talk to me and I will explain as best I can. So yeah, I think that's it. Balancing equations, especially really simple ones like, this. I think we all kind of get what's going on with that. So yeah, thank you so much for watching. Feel free to reach out if you have any questions, comments, concerns, all that jazz. So thank you so much.